So let's now look at the amplitude versus energy question that we had asked. Can the energy minus half m omega squared a squared, this gap between the energy and the classical value, be reduced beyond half h cross omega? Or at least can we do this with things which are really oscillating? So if you write the energy, which is the expression value of the Hamiltonian, no, the energy is the eigenvalue of the Hamiltonian only for stationary states. For a general state, it's the excitation value of the Hamiltonian that we are using. So p squared excitation value by twice m plus half m omega squared times x squared excitation value. And on the other hand, we know for a harmonic oscillator, the expression of x at time t, this is what the Ehrenfest theorem told us, is the expression value of x at time 0 actually, cosine omega t, plus expression of p by m omega, that's the velocity at t equal to 0, times sine omega t. Again, the familiar classical oscillation formula. Now, given this, you have a cosine term and a sine term. You all know how to calculate the amplitude for that. The amplitude squared is given by this squared plus this squared. And so if you subtract half m omega square a square from E, this is my E, the first bracket, and the second bracket is minus half m omega squared times a square. Can easily see by gathering terms together that this simply becomes p expectation value squared minus p squared expectation value minus p expectation value squared by twice m, plus a similar quantity with half m omega square coefficient for x. It is nothing but delta p whole square by twice m plus half m omega square delta x whole square. My next step will be exactly trivial algebra. These are, of course, numbers. Now they are no longer operators. These are just simple numbers. So we can use ordinary algebra with this. We can actually write this in this form. The sum of two squares, a square plus b square, and this I can write as delta p minus m omega delta x whole square, a minus b whole square, plus twice ab. Now notice that here we have something which can never give me a negative result. Delta p, delta x, all these are positive, are real numbers, in a positive real numbers. This can never give me a negative value. And delta x, delta p can never be smaller than h cross by 2. And this immediately tells us that the half h cross omega that we had obtained for the ground state is actually the minimum possible value. You cannot go below half h cross omega as far as this gap is concerned, at least not for a harmonic oscillator. But can you get this without using the ground state? Well, you can get this to be equal to half h cross omega if two things happen. If delta x delta p is equal to h cross by 2 omega, half h cross omega, exactly that. Delta x delta p is exactly half h cross. And if this term is 0. But that is exactly what a coherent state obeys. So for a coherent state, I've said apart from the ground state, but actually the ground state is also a coherent state corresponding to alpha equal to 0. So the coherent states satisfy the lower bound, half h cross omega. So you can have non-trivially oscillating systems, which will actually give you exactly the lowest possible gap between energy and the classical energy from the amplitude.